Our today's experiment is your experiment number 5. Your experiment number 5, that is design of rectifier using PN junction diode, right? So which rectifier we will be studying here is your half wave rectifier. So we have the basic knowledge of diode and rectifier as well as capacitor filter, which we have covered right in the lecture. Now the two objectives are we need to study the operation of half wave rectifier, first with filter and second without filter. Okay, and then when we will get convinced and when we will see the waveforms, okay, after that we need to measure the value of voltage and then observe waveforms at the output of the rectifier. Okay, so for these things we need several components, like we need a breadboard, diode, resistor, capacitor, etc., right? So resistor specifically we can have of 100 microfarad, okay, or maybe 4.7 microfarad, any one of it. Okay, so we will be using a 100 microfarad capacitor, a resistor of 1 ohm or 2.2 kilo ohms. Now this theory, all of you know this theory. Okay, so half wave rectifier, first of all we will try to build this circuit on the Tinkercad. Am I audible clearly?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, okay. So again, we want to go on Tinkercad. So I will just go on the Tinkercad and then I will
Yes, sir.
open the circuit, right? And I will create a new circuit, although I have a circuit of this created, but I will just show you how to create it. Okay. So those who have missed first lecture, okay, for them, again, it is very simple thing. So right side, there is a library. I want a breadboard. So I just kept the I just took the breadboard with me. Okay, and then I'm just relocating it as per my convenience. Okay, now what I want to build a half wave rectifier circuit. Okay, so how to build a half wave rectifier circuit? So for that I need a diode. Okay, so let us say that I want a diode for it. I want a diode for it. So normal diode I will be taking and I will just attach it. Okay, if you want to rotate, just R for rotate. Okay, now which is anode and which is cathode? So you can see a silver ring, right? So whenever whatever ring is there, so whenever there is a ring, that is your cathode. Okay, now what else you want? You want a rectifier, then you want a resistor. Okay, so here, from here I am taking the resistor directly. Okay, and I'm just placing it here. Okay, now I want to connect the cathode of the resistor diode to a resistor, so I'm just connecting it here. Okay, so maybe with green wires I'm connecting. And now this point is always connected, right? Because we have seen the breadboard, it is vertically shorted. All these lines are vertically shorted, right? Now what is the value of the resistor? That is 1 kilo ohms. Okay, so that is okay, that is not a problem. Okay, now the basic question is that if I want to observe the output across the resistor, how to observe it? Yes, which component I will be using? Yes, can you?
Multimeter, sir.
Huh?
Oscilloscope.
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 Oscilloscope. Yeah.
Okay. So here I'm just keeping the oscilloscope here and I want to observe. I want to observe the multimeter. Sorry, I want to observe the output. Okay. So this is negative and positive. So let me connect this positive across RL. Okay. So across load, I'm just observing and this is connected to negative. Yes, no?
Yes.
For
Yes,
negative,
sir.
I'm just using black wire. Is it okay?
Yes,
Yes,
sir.
sir.
Yes.
Yes, sir.
Now, what should be given to the input? What should be the given to the input? This sine wave. So from where I can generate the sine wave?
Yes.
Function generator.
Very
Function
good. So
generator.
here
Generator.
I can use function generator, right? I'm just dragging and dropping it here. Okay. Any problem in this?
No, sir.
So
No,
I'm,
Yes,
sir.
sir.
I want to shift this here. So I'm just increasing some aesthetic looks, right?
Yes.
Yeah. And then what I want to generate, maybe a frequency, okay, where the peak to peak amplitude is, we can say पीक टू पीक एम्पलीट्यूड फ्रीक्वेंसी कितना लेंगे हम लोग 60 और 50 हर्ट्ज राइट हर्ट्ज लेते हैं ओके
Okay.
एंड amplitude maybe we can take it okay 5 volts peak to peak shall we
Select.
or maybe 6 volts we can take okay and DC offset we can keep it as 0 and we want which wave sine wave okay and then this is given to negative part is connected here to one of the terminal of resistor correct and positive part where it is connected
Diode.
डायोड सो डायोड को यहाँ पर कनेक्ट करेंगे यहाँ पर कनेक्ट करेंगे नीचे या
So,
ऊपर
ऊपर ऊपर.
नीचे ना
नीचे नीचे
क्यों क्योंकि ये सब शॉर्टेड है राइट कैन यू सी अ ग्रीन हाइलाइटेड लाइन
Yes, sir.
Yes, sir.
okay and positive so I will just put it on green color about it getting now now shall I run the simulation so let me check just I will make it as okay so
Yes, sir.
yeah now if you want to see the input waveform right how you can see again you can use one more oscilloscope right one more
Yes,
oscilloscope
sir.
in the input okay so you want to observe it you want to observe this waveform so what you can do it that you can just give this connection here getting why I am connecting this thing because I just want to see observe the input also right तो इसको मैं ब्लैक कलर दे देता हूँ ओके सो व्हाट इज द प्रॉब्लम यू नो दैट द प्रॉब्लम विल बी लेट मी do it 10 milliseconds okay so I will start the simulation so you can see that input is a sine wave ये पैरामीटर्स है इनपुट के ऐसे दिख रहा है इनपुट आपको ओके कैसे दिख रहा है साइन वेव पीक टू पीक 6 वोल्ट ओके फ्रीक्वेंसी इज 50 हर्ट्ज एंड आउटपुट इज can you see is it output of half wave rectifier exactly it is output of half wave rectifier right yes
Yes,
Yes,
sir.
sir.
Yes, sir.
यस सर
Yes, sir.
okay so are you convinced that this circuit is working properly
Yes, sir.
यस सर
Yes, sir. Yes, sir.
okay okay now now so this is simple the working of half wave rectifier any problem in this I guess there is no problem right
Yes, sir.
okay now can you calculate vm I'm just zooming it just calculate vm here one division corresponds to how much
2.5.
so can I say it is 2.5 volts
Yes, sir. Approx.
approx 2.5 volts correct
Yes, sir.
यस सर
Yes, sir.
यस सर
इनपुट में हमने कितना दिया है 6 वोल्ट्स दिया है
6 वोल्ट
आउटपुट में 2.5 मिल रहा है मतलब 40% एफिशिएंसी है ना ऑलमोस्ट
Yes,
मतलब
sir.
दिस इज नॉट अ
Yes,
कैलकुलेटेड आंसर राइट बट एक आपको लॉजिकली मैंने बता दिया हाफ वेव रेक्टिफायर का एफिशिएंसी इज वेरी वेरी लेस राइट
Yes, sir.
ओके
यस
नाउ just simple observations we will be seeing right so can you calculate VLDC
Yes, sir.
VM by pi
2.5 by
what is RL
R at least. Sir, resistance is
1 kilo ohms
One,
resistance का वैल्यू क्या लिया था 1 kilo
1 kilo ohms.
so can you
V is equal
calculate
to IR.
IM will be
V,
VM by
VM by
RL,
resist 1000.
RL, right?
Yes, sir.
Okay, we are considering here ideal diode. Okay, now, so you can calculate all the parameters, isn't it?
Yes, sir.
Okay, okay. Now here you can see, okay, ripple factor, that is another part, but you can just note down some observations, right? That let us say that I want input, what is the input voltage? Input voltage VM was 3 volts, right? Peak to peak voltage was 6 volts. तो input में कितना है
3,
VM?
3
3
volt.
3 volts, right?
3 over.
Okay. Now, diode selection VLDC कितना मिल रहा है आपको?
Sir, 2.5.
हाँ. So let us say that VLDC, that is your 2.5. That is not VLDC, right? That is VM, output VM. Okay.
Sir, 2 point. So
हाँ.
by pi.
Correct. So whatever VLDC you are using, just write it here. Then peak inverse voltage will be, इसका इनपुट में VM कितना है? 3 volts. So peak inverse voltage will be 3 volts. Okay. And what will be ILDC? VM by pi or VM by RF plus RL, right? So you can just write here how much is the milliampere, okay? And then therefore we are selecting this kind of diode, right? So normally for rectifier, right, we will select which diode? We will select rectifier diode, right? So which is this diode, you know? Normally the rectifier diode is nothing but your, we can say IN 4007, right? So this is your normally a rectifier diode. You can get the features of this rectifier diode in the sheet called as data sheet of the diode, right? So here you can just check it out that let us say that you want peak inverse voltage is 3 volts, right? So here just you can see what is the peak inverse voltage, okay, or what is the forward current which it can withstand, right? And all the specifications, what is the maximum temperature at which it can operate, okay? So here the peak repetitive reverse voltage, right, that is your peak inverse voltage for IN 4007 is 1000 volts, right? Correct?
Yes, sir.
चलेगा फिर ये डायोड हमारे लिए? ऑफ कोर्स चलेगा, राइट? रेटेड
चलेगा
वोल्टेज
सर.
काफी ज्यादा है. Getting?
Yes, sir.
Yeah, so like this you can just select any diode. So here you just note it down that you need to write here the diode number which you are using, that is IN4007 or 4001 is also fine for you. Okay, now what is load resistor we are selecting? 1.
1 kilo.
1 kilo.
And what is the capacitor value which we are using? 100 microfarad, right? Correct?
Yes, sir.
Yes, sir.
Yes.
Now observation table, right? So I will just write one of the observation. You can just repeat it and you can complete the observation table. What was VM?
Sir, 2.5.
Okay. Now what is my suggestion is that yeah, so VM is 2.5, right? Now what is VLDC?
2.5 by pi.
Bye bye.
2.5 by pi.
Yes. What is VRMS?
1 point. Yes, sir.
VM by 2.
2.
What is ILDC? Can you calculate ILDC? VLDC divided by RL, correct?
Yes, sir.
Right? Okay. Now this is rectifier with capacitor filter or without capacitor filter?
Without.
Without one.
So what is the theoretical value for ripple factor?
1.2.
1.21. What is the practical value? Now how to calculate the practical value? So here we will go in the section called as ripple factor section. You can see my screen, right?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Now what is so this is your theoretical value of a ripple factor, right? Now how to calculate the practical value? How to calculate the practical value? So you got the value of VRMS.
Yes, sir.
You got the value of VLDC.
Yes, sir.
Yes,
Yes,
sir.
sir.
You got the value of VLDC. So can you use this formula, right? And put the values which we have observed from this table. Which table? Just now we have completed this practical table. You know VLDC, you know VRMS, and just find out whether what is the practical value, right? By using the formula. Yes. Can you?
Yes, sir. Yes, sir.
So it
I will
should be
try.
near to 1.21. Okay.
Okay, sir.
Yeah. So this is your part which you need to do. Any problem in this?
No, sir.
Can you
No,
calculate
sir.
now?
No, sir.
Can you calculate by using this formula? Just take down the values. What is this value, by the way? 2.5 divided by pi. Can you tell me what is the value?
Sir, I guess approximately 0.7. More than 7 point something, 7.3. Wait.
0.8, sir.
0.8. Okay, let us take 0.8. Okay, 0.8 and 1.25. Okay, so can you just calculate this value? It will be 1.25 square minus 0.8 square divided by 0.8 square. उसका रूट लेंगे तो क्या आएगा बोलिए? This will be 0.8 का square. Sorry, this will be 1.25 square. Right? And this VLDC is what? Okay, so can you calculate it? Just calculate and tell me what is the value coming. That value you have to write it here. So you have the scientific calculators with you.
And sir, in phone or
For now, it's in phone.
What?
for now
For
we
now,
are
it's in
using
our
phone.
phones.
Huh?
It's for now
Mobile
we are
phones, sir.
using mobile phones.
Okay, okay, mobile phones. Okay, no problem. So you can just simply can you calculate the values, guys? So it will be, yes, root of 1.25 square minus 0.8 square divided by 0.8 square, right? So what value you are getting?
1.2, sir.
1.200.
1.200.
1.200,
00.
right? So this is a ripple factor which we have calculated from the practical values, right?
Yes, sir.
Yes, sir.
Yes.
Easy.
Yes, sir.
Okay.
Yes, sir.
So you got this value, right?
Yes,
Yes,
sir.
sir.
Value
Yes.
you got it, right? Okay. So this part is completed. Any problem in this?
No, sir.
No, sir.
Any problems? So note, students are instructed to do all the necessary calculations on the separate sheet. So calculations आप attach कर दीजिएगा इसके साथ में जो मैं बता रहा हूँ ना वो. Any problem in this, guys?
No, sir.
No, sir.
Easy है ना?
Yes, sir.
Yes, sir.
Yeah, it's very easy. Now, what is the thing, you know? Now we need to do it. कैसे करेंगे अभी इसको? Now we need to attach a capacitor filter, right? So now we need see observation table. Now next part is we need to find all the values with capacitor filter. Okay. Now before that, I will just go on the circuit, and now I will just minimize it. Okay. Okay. Now let us have a multimeter. Let us have a multimeter just for. So this is your multimeter. Okay. And this I'm keeping here, and I'm just configuring it to measure the voltage, and I'm just measuring the voltage across resistor by using the multimeter. Okay, so I will use some different color, right? Which orange I will use? Okay, so I'm just trying to measure the output across resistor by using the multimeter. How much it is?
Sir, it's
It's varying, but it's,
varying.
let us say that it is 0.8 volts, right?
Yes, sir.
0.8, 0.7 volts. Okay. Is it DC voltage, VLDC, correct?
Yes, sir.
Yes, sir.
तो हमारा जो कैलकुलेशन था वो बराबर था ना 0.8 वोल्ट्स. Yes, no. Whatever value you are
Yes.
getting,
Yes,
Yes,
sir.
sir.
ये कौन सा है? VLDC है, right?
VLDC. Yes.
Yes,
Good,
sir.
very good, very good. Okay. Now we will be, we want to study half wave rectifier with capacitor filter, right? So again, I will go back. I will stop simulation, and I want to connect. Capacitor in parallel with this resistor.
Resistor.
Okay. So I will use capacitor. तो ये polarized capacitor लेता हूं मैं. Okay. I'm keeping it here. Okay. Okay. इस साइड में लगाऊंगा, चलेगा?
Yes, sir.
And this is your negative value, right? थोड़ा rotate करो इसको मैं. Okay. Now I'm just keeping it here. तो इसको parallel में लगाना है, right? So parallel, how I will connect it? So this I am connecting to directly here. Connect कर दूं मैं इसको?
चलेगा सर.
चलेगा. Okay. तो समझने में आपको थोड़ा सा easy जाएगा, right? And this I am connecting it here directly to the resistance. So can I say capacitor is connected in parallel with the resistor?
Yes, sir.
Yes,
What is the
sir.
value of the capacitor? Let us say 100 microfarad.
100 hours.
Voltage is 16 volts, right? So it can withstand that. So that is the rating of the capacitor. This is your polarized capacitor because here positive and negative is there. Okay, अगर positive negative आपने उल्टा कर दिया तो फिर your circuit may not work. Okay, any problem in this?
No, sir.
Now capacitor जब लगेगा तो क्या होगा? Ripples will increase or reduce.
Reduce.
मतलब AC filter out होगा. तो
Yes,
वेवफॉर्म
sir.
में क्या दिखना चाहिए हमें? चार्जिंग, डिस्चार्जिंग,
Charging or discharge.
चार्जिंग,
Discharge.
डिस्चार्जिंग. आज ही सुबह देखा ना हमने?
Yes,
Ah,
sir.
sir.
Yes.
Yes.
Yes, yes. So we have seen this in the theory lecture. So let me run this. And let us see what is the output. Wow. So I'm getting charging and discharging. I will just zoom it for you. Can you see? Charging, discharging, charging, discharging, charging, discharging. Is it correct?
Yes, sir.
So
Yes,
can you
sir.
see the output of the capacitor filter? Yes.
Yes, sir.
ओके. तो अभी सुनिए, एक सिंपल बात बताता हूं मैं कि जब कैपेसिटर फिल्टर लगा तो क्या होना चाहिए? आउटपुट में एसी ज्यादा रहना चाहिए या डीसी ज्यादा रहेगा?
DC.
अरे
DC.
आउटपुट में डीसी ज्यादा रहेगा, एसी कम हो जाएगा.
Yes.
Yes, sir.
Ah, sir.
Yes, sir.
सो कैन आई से दैट दिस वोल्टेज हैज इंक्रीज्ड?
Yes.
Yes, sir.
एसी डिक्रीज हो गया है.
Yes, sir.
ओके. यस, नो?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes,
So
sir.
now let us see. So here, what is the value of capacitor? 100 microfarad. You can do it for some another value also, right? You can do it for 2.2 or 4.5 microfarad also. Okay. Now VRPP VLDC. What is VLDC, by the way? What is VLDC?
Sir, that multimeter.
2.17 volts. Is it?
Yes.
Yes, sir.
Yes, sir. Appropriate.
Okay. Good. Now just see. This PPT. Okay. So we need to find ripple factor, but before that, this is your VLDC, right? What is voltage across capacitor?
2.17.
2.15, right?
Yes,
Okay.
sir.
Can I say that is the voltage across the resistor, RL? So if you know the voltage across resistor, that is output voltage, can you find ILDC, that is current through the resistor? What is ILDC? VLDC divided by RL, what is
RL.
1 kilo ohms,
1000.
correct?
Yes, sir.
समझ में आ रहा है?
Yes, sir.
इजी है?
Yes, sir.
तो ये टेबल आपको मिल गया फिर?
Yes, sir.
This will be
2.1.
and this will be
2.17
2.17.
milli है.
milliampere, correct?
Yes, sir.
Yes, sir.
सिंपल है.
Yes, sir.
VRPP बचा है ना?
Yes, sir.
Okay.
Yes, sir.
Before that, if you want to find the theoretical value, of ripple factor, how you can find it out? So there is a formula which I was supposed to tell you in the lecture. This is the theoretical value of ripple factor. 1 upon 2 FRC root 3 or 1 upon 2 root 3 FRC, right? What is F, by the way? What is F? Okay,
Frequency.
calculate करके देखिए. 1 upon 2, okay. C का वैल्यू पता है, R का वैल्यू पता है. What is F? What is F? Frequency कितना था?
Frequency.
Frequency
50
कितना था?
50 hertz.
50 hertz.
60 hertz.
50, 50, 50.
Yes, sir.
Okay. Okay.
Yes, sir.
Now just note it down. Okay, just note it down. What value you are getting, just note it down. What you will be getting value. I will also note down. Okay, I will say a very good observation on this, right? So what is ripple factor? 1 upon 2 root 3 FRC. So 1 upon 2 root 3, 50, 1K, 100 micro. So have anyone calculated this value? कोई है फास्ट जिसने कैलकुलेट किया होगा? Or else do it. So it will be 0.1 multiplied by 1 by root 3. ये तो कर सकते हो ना आप? देखो,
Sir, 0.
माइक्रो, किलो,
0.05.
057.
मिली और ये किलो. 5 to 10. 10 का उल्टा 0.1 मल्टीप्लाइड बाय 1 by root 3. ऐसे ही करके थे ना फिजिक्स में कैलकुलेशंस?
Yes, sir.
मैंने तो ऐसे किए थे.
0.05.
0.057.
0.5, राइट?
Yes, sir.
देखो पहले रिपल फैक्टर कितना था? 1.1. कैपेसिटर फिल्टर लगाने के तुरंत बाद कितना हुआ? 0.05. कितना कम हुआ रिपल फैक्टर? समझ में आया आपको?
Yes,
Yes,
sir.
sir.
इजी है?
Yes, sir.
Yes, sir.
ओके. नाउ अभी इसमें और थोड़ा मॉडिफिकेशन करूंगा मैं. जस्ट होल्ड ऑन. ओके. नाउ हाउ टू कैलकुलेट थ्योरेटिकल वैल्यू? थ्योरेटिकल वैल्यू कैसे निकालेंगे? सो बाय यूजिंग दिस फॉर्मूला. व्हाट इज VRPP? What is VRPP? Yes. What is VRPP? ये जो हमारा वेवफॉर्म है, राइट?
550.
ये जो हमारा वेवफॉर्म है उसमें सबसे पीक से लेकर एक्स एक्सिस तक. सो दिस इज योर VRPP. कैलकुलेट करने के लिए V rect लगेगा. So what is this V rect? This is nothing but VP rect is nothing but this. Correct?
Yes, sir. 2.1, sir.
So हमारे यहाँ पर कहाँ पर है देखिए. What is this value? Yeah. So I will have to zoom. थोड़ा सा zoom करता हूँ मैं for your understanding purpose. Okay. Now, so can I say that okay? चलो मैं क्या करता हूँ ना. Okay. So now, can you see this thing? Someone is there in the meeting room. Okay, Swaral. So I'll go here. Now, can you tell me this value? between this point, right? See the lower end. Just take a thin line, very thin line. Can you see, can you calculate this distance? 1 unit corresponds to? So can I say this is nothing but your, this value, right? This is same, this value, right? Correct?
Yes, sir.
Sir.
Yes,
Yes,
sir.
sir.
Okay. Okay, anyway. So I'll just rub this thing. Okay, so now what is this value, by the way? Have you calculated it? Or you know what is this value? What is this value now? See, this one division corresponds to 1 volt. Am I audible? So 1,
Yes, sir.
2, maybe
2.1%.
2.5 volts, right? Whatever reading you are getting through multimeter, that is how much?
2.4 volt.
Okay, so that is average value, right? We are taking peak value. Okay, getting what I am trying to tell you. Okay, 2.5 volts.
Yes, sir.
So now this is 2.5 volts. This is 2.5 volts. Now can you calculate this thing VRPP? Can you calculate this thing VRPP? It will be 1 divided by F. What you will take F? Okay,
50,
सुनिए
50.
50.
Yeah.
ओके आप
50.
F50 लेंगे या 100 लेंगे वो बताइए मुझे इनपुट में कितना है फ्रीक्वेंसी 50 तो आउटपुट
50.
कितना
50.
आएगा 100 या 50 आउटपुट में कितना आएगा 100 या 50 आउटपुट में 100 आएगा ना ट्वाइस होता है ना फ्रीक्वेंसी राइट okay so anyway I'm
Okay, sir.
considering 50 right I'm just considering
Okay.
50 here okay so it will be 50 multiplied by f rl is 1k multiplied by how much
100 micro.
100
into
100
10 to the
micro
power
multiplied by 2.5 so how much it is coming see so this micro milli this will get cancelled 5 into 2.5 1 divided by 2.5 into 5 kitna 12.5 right
12.5.
so you got this value right VRPP okay so this is nothing but 1 divided by 12.5 divided by VDC कैसे calculate करेंगे so VP rect
Sir,
VP rect हाँ yes
सर वो VP रेट ऊपर मल्टीप्लाई करने है कि नीचे नीचे
कहाँ पर
जो 2.5 वैल्यू है वो
हाँ हाँ तो
ऊपर
वो
मल्टीप्लाई
ऊपर ही ना ऊपर ही आएगा ना
ओके
okay that will be in the numerator multiplied by numerator okay and VDC what is VDC VDC will be इसको अगर सिंप्लीफाई करूंगा तो this will be 1 minus 1 divided by 2 into 50 into yes 1 into 100 ये किलो है this is micro so how much it is this micro kilo this will be getting cancelled and then this is how much yes 10 so it is 1 minus 1 by 10 is it 0.9 correct
Yes, sir.
multiplied by 2.5. So how much it is? Okay, so let me write it here. Let me write it here. 0.9 multiplied by 2.5. So what is the calculation final? What is finally ripple factor? How much it is?
Sir,
Huh?
that VRPP 0.5 na?
Huh?
Because 2.5 is multiplied in the numerator, so how will it come 1 upon 12.5?
Sir, 2.5 should be
Ah, yes.
multiplied
Sorry,
upwards.
2.5
sorry,
So,
sorry.
numerator.
This 2.5 will be in the numerator. Yes. 2.5. So it will be
Or it will be
2.5.
0.8.
How much it
Yes,
is?
I was also
2.5
thinking the
divided by?
same.
0.5.
Good, good, very good. I was just checking whether you are sleeping or not, right?
Thank you, sir. Thank you. No, I am not speaking.
No, no. Okay, okay.
I asked, sir,
So कितना हुआ ये? यहाँ पर कितना है? 5.
2.5,
5.
5,
So it will
0.5.
be 0.5.
0.5.
Very good. So I will write it here. 0.5 divided by. Is it correct now?
Sir,
Yes.
we need to also change our.
Hmm. So is it like this? Just check it out. 250. 2 5s are 10. 1 minus 0.9 into 2.5. I guess this is correct, right?
Yes, yes, sir.
Yes,
So
sir.
it is
Yes, sir.
0.9 into 2.5. So this will be 5. And 1 divided by 5 nines are 4.5. How much it is? 1 divided by 4.5, how much it is coming? 0.
Why?
0.2.
0.
0.2.
Yes, 0. Hello,
2, 2,
0.2, sir. 2,
2, 2.
2, 2.
2,
0.22. Okay. So this is your practical value, right?
Yes, sir.
Correct. Sorry, yeah, this is your practical value, which is coming out from the calculation. So you got your theoretical value, and we have the ripple factor practical value from here. So you can just write out here. Whatever value you are getting, you just write down here. Can you write down this value, theoretical value, whatever you are getting, and this is your practical value. Okay.
Yes, sir.
Is it correct?
yes, sir.
Okay. Any problem in this?
No, sir.
No, sir.
So conclusion, you can write on your own. Okay. And then these are the post-lab questions, right? Just neglect this
Okay,
rubrics.
sir.
This rubrics will be renewed, and I will be giving in detail the rubrics. Okay.
Okay.
So any difficulty in this, guys? So I will just
Okay.
have circuit in front of you. You just check it out. Okay. Just see for a couple of minutes, and then you can ask me the questions, right? Now we can just see, just look to the output, right? What happens if I'm just changing this to, let us say, 50 microfarads, right? 50 microfarads karunga. I'm just changing the property to 50 microfarads. Are you seeing any change? चार्जिंग डिस्चार्जिंग थोड़ा सा मतलब उसका ये कम हो गया, राइट? See
Yes,
peak
sir.
to peak voltage.
Peak to peak.
Okay.
Yes.
And then see, I will just increase the value of resistance to 10. So discharging time काफी बढ़ना चाहिए. तो बड़ा है discharging time. बड़ा है ना?
Yes, sir.
चार्जिंग बहुत कम हो रहा है,
Yes, sir.
ऑलमोस्ट
Yes,
डीसी
sir.
हो गया.
हाँ.
ओके. यस नो, अभी फिर से इसको थोड़ा सा हम क्या करते हैं, 500 करके देखते हैं.
Sir.
और पूरा डीसी हो
Straight.
गया, है ना?
Yes, sir.
Yes, sir.
इसको सिर्फ 2.2 माइक्रोफैराड करके देखेंगे. गेटिंग?
Yes, sir.
Yes, sir.
So आप different readings के लिए you can just do all the calculations, right? And at least what I'm expecting is that you should take 2 readings by your own, and you should do the calculations, and you should write it here. Okay. So rest all that part is explained in theory, and this is the practical. I guess this session was good to understand that how this rectifier is working, and how means we can understand that how the filter is filtering the AC supply, AC, which is coming out from the rectifier, right? Any problem in this?
No, sir.
Sir, sir, observation table and post lab questions we have to write in different pages.
देखिए फॉर एग्जाम्पल आप यहाँ पर टाइप करेंगे, ये सब टाइप कर सकते हो ना आप लोग?
Yes, sir.
Inclusion also you can type and post lab questions, right? इसके नीचे इसको हटा दो, right? And then you just write the post lab questions and click the picture and attach it here. Getting? समझ में आया?
हाँ सर.
Yes, yes. And again, one thing, right? That in today means in lecture also I have told that submission requirements, right? So what are the submission requirements? So when you get this file, okay, this thing I don't want, right? This thing I don't want, so I will just delete it, okay. And then here what I want, you know, this I want, aim I want, and this I don't want. I don't want this thing, okay. So I will just not have all this theory part which everyone has, right? So procedure also I don't want, so I will just remove it, okay. And directly aim के बाद में I want observations, right? And then here expected waveforms, okay. This also I don't want, okay. Instead you can put a screenshot of your waveforms, whatever you are getting. And here instead of this you can do here calculations, okay. And calculations आप हाथ से करेंगे तो फिर calculations का part आप conclusion के बाद में डाल सकते हो. And after that I want post lab, okay. Yes.
Okay, sir.
Yes, sir.
Now
Okay, sir.
just for the
Sir.
reference point, just wait, I will complete and then you can talk, okay. Is it okay?
Yes, sir.
Yes. So let us say that okay, this is only for reference I am taking, okay. Let us suppose who is this Jayesh, right? Jayesh ने submit किया है. So I will put your marks. Okay, very good. So Jayesh have written by using pen tab, so not an issue. Okay, very good, Jayesh. So देख रहे हो आप? So this is expected. Good, very good, very good, very good, very good, very good. And yes, okay, good. And okay, answer for post lab question. थोड़ा सा पोस्ट लैब क्वेश्चंस ना थोड़ा डिटेल में लिखेंगे तो अच्छा होगा, ओके, विद डायग्राम. जैसे आप ये हो गया कैथोड रे ऑसिलोस्कोप, इसका थोड़ा आगे वाला कुछ फ्रंट पैनल बना देंगे वगैरह तो फिर दैट विल बी बेटर, ओके. यस, एनी प्रॉब्लम?
No, sir.
लेट अस चेक दूसरे ने क्या किया है. ओके, सार्थक ने क्या किया देखेंगे. So very good, you three have voluntarily submitted, so not an issue. I will Jayesh is there in the meeting?
No,
So
sir, वो
good.
बैटरी का है.
Okay, so good that he have not. Okay, ये भी सही है, लेकिन इसमें देखिए प्रॉब्लम क्या हो रहा है, ओवरलैप हो रहा है, दिख नहीं रहा है. So ऐसा नहीं चलेगा, okay. सार्थक है क्या मीटिंग में? Okay, and then conclusion good, and then this good, very good, very good, very good. And post lab questions, okay. इसने देखिए थोड़ा प्रॉपरली लिखा है ना, फॉरवर्ड बाइसिंग क्या होता है, रिवर्स बाइसिंग क्या होता है, राइट? तो थोड़ा इस तरीके से एक्सपेक्टेड है क्वेश्चन आंसर्स, राइट? ऑल्दो इसने आखिरी के दो थोड़े कम कम लिखे, बट ओके, उसने फर्स्ट सबमिट किया है तो मैं आई विल जस्ट कंसिडर, ओके. एंड लेट अस सी, वैभव है मीटिंग में? वैभव इज देयर इन द मीटिंग गिरा से? सो गुड, वेरी गुड, वेरी गुड, ओके. सो ये देखिए, ये एक पेज पे एक ही चाहिए मुझे, ये कैसे ध्यान में आएगा, है ना? यस, एम ऑडिबल?
Yes, sir.
हाँ. सो एक पेज, इसके नीचे फिर दूसरा पेज, राइट? So like this, he should have zoomed it, right? जैसे पेज का सेटिंग हम कर सकते हैं ना, like वर्ड में मुझे अगर कोई पिक्चर डालना है, okay. So I don't have any picture. Let us check main pictures, right? Okay. So Let me copy this picture and let me put it on the new page for you. Okay, so this is for you from my side. Enjoy it. Okay, so ये जो है ये next page में गया. So इसको कैसे करना है, ऐसे पकड़ना है, ड्रैग करना है, तो थोड़ा अभी अच्छा लगता है ना, बड़ा बड़ा फूल है ना.
Yes.
Okay, okay, good. So all the best from my side with these flowers. Okay.
Okay.
Okay. चलिए फिर.
Okay.
So
Thank you, sir.
I will stop recording. Any difficulties?
No, sir.
No, sir.